Hello everybody, welcome to lecture 3 of our electrochemistry series. Today we'll dive into the topics Kohlrausch law and its applications and factors affecting electrolytic conductance and so on. We'll explore the fundamental principles and concepts that govern electrochemical reactions. Let's get started and see how these principles apply to real world applications. So let's get started. So what is Kohlrausch's law? It's very important. Kohlrausch's law states that the equivalent conductivity of an electrolyte at infinite dilution is equal to sum of ionic conductivities of its constituent ions. So what is Kohlrausch's law? The conductivity of a salt like NaCl or any kind of electrolyte, for example in water, I am talking about the conductivity of a salt, that is NaCl, or any electrolyte in water, that will be equal to sum of conductivity of its individual ions, of course, from which it is formed. For example, table salt, that is NaCl, dissolves in water, that will split up into two ions, Na positive sodium and Cl negative chloride. According to Kohlrausch's law, the conductivity of salt solution is the sum of conductivities of Na positive and Cl negative ions. We can also take another example, like if we have a solution of potassium nitrate, that is KNO3, its conductivity would be the sum of conductivities of K positive potassium and NO3 negative nitrate ions. And also, what is conductivity? We have already studied about conductivity in our previous lectures. Again, I'm telling here, conductivity is what? The ability of a material like a solution or a wire to allow electricity to flow through it. Simple words, we can say conductivity measures how well something can carry electric current. Example, even in last lecture I gave the example of water flowing through a pipe. If the pipe is clear and wide, water flows easily. Similarly, materials with high conductivity allow electricity to flow easily. So let's come back to our topic, that is Kohlrausch's law. What is it? The conductivity of a dissolved substance, it might be electrolyte, is equal to sum of conductivity of its individual parts. Okay. So now we are going to start. It is also known as, on the behalf of its statement, Kohlrausch's law of independent migration of ions. That's what I already explained to you in very simple words, that conductivity of a dissolved substance, that is electrolyte, that will be equal to sum of its constituent ions. Okay. Independent migration of ions. Independent means freely. They are migrating, they are moving from one place to another. Of course, the ions. So that's why the statement says that equivalent conductivity of an electrolyte at infinite dilution is equal to sum of ionic conductivity of its constituent ions. Now, the mathematical expression, this. I am talking about mathematical expression. It is studied as this. This is called capital lambda. Okay, so capital lambda is equals to small lambda naught plus small lambda naught minus, where this lambda naught is equivalent conductivity at infinite dilution, lambda naught plus is ionic conductivity of cation, and lambda naught minus is ionic conductivity of anions. Okay, so now we are going to study about the applications of Kohlrausch's law. So first application is, we use it in the calculating conductivity, as I already stated in the statement, that it will be used in calculating conductivity. Kohlrausch law helps calculate the conductivity of electrolytes at infinite dilution. Another is determining ionic conductivities. It allows determination of individual ionic conductivities of cations and anions. So that's why the name was given a independent migration. So this indicates that why it was the name was given. And we can use these, this Kohlrausch law in understanding electrolyte behavior. The law provides insights into the behavior of electrolytes in solution, that how they are behaving, how they are migrating from one place to another. So these all are some examples, some applications where we can apply Kohlrausch law. So these are basically three applications which I stated in very simple words. Now we are going to do factors affecting electrolytic conductance. So first of all, what is the meaning of this factors affecting electrolytic conductance? See, things that influence how well a liquid must be solution, things that influence how well a solution can carry electricity. So it is the meaning of this line, factors affecting electrolytic conductance. For example, amount of salt and sugar dissolved, more dissolved, better conductivity. Like in everyday terms, we can understand it by the example. Think of it like water flowing through a pipe. Alright. Factors like pipe size, water pressure, and pipe material that affect flow. Similarly, these factors affect how well electricity flows through a solution. So these we are going to explain one by one factors. First is interionic attraction. As it is stated here, interionic attraction between ions of solute is more, then the conductance will be less. The meaning of this is stronger interionic attraction can reduce the movement of ions, thereby decreasing conductance. See, oppositely charged ions attract each other. Already we know that, which will slow them down and affect how well electricity flows through the solution. So next is polarity of solvent. Now term polarity, this refers to the solvent's ability to separate and stabilize ions. Polar solvents like water have a slight positive charge on one end and a slight negative charge on another. So how does it affect electrolytic conductance? See, polar solvents dissolve ions more easily, allowing them to move freely and conduct electricity. That will also, making it easier for ions to move. That will reduce attraction. And non-polar solvents like oil don't dissolve ions well, resulting in poor conductance. So polar solvents help ions move freely, making it easier for electricity to flow. Non-polar solvents don't help ions move as well, making it harder for electricity to flow. So next is viscosity of medium. First of all, the term viscosity. This refers to the thickness or resistance to flow of a liquid. Thicker liquid like honey have high viscosity, while thinner liquid like water have low viscosity. So if there will be higher viscosity, that will slow down ion movement, making it harder for ions to move and conduct electricity. It will also reduce conductance, resulting in lower electrolytic conductance. So thicker liquids slow down ion movement, making it harder for electricity to flow. Thinner liquids allow ions to move more easily, making it easier for electricity to flow. And another is temperature. So if temperature is increased, ions move faster and more freely. That will resulting in better electrolytic conductance. Reason is higher temperature provide more energy for ions to move. That will overcome attractive forces and increasing conductivity. See, warmer solutions conduct electricity better because ions move more easily. Cooler solutions conduct electricity less because ions move slower. And now another is the hydrated size. It refers to the size of an ion when it is surrounded by water molecules. See, water molecules, water word refers to hydration shell. So if the size is larger, if larger hydrated size, that will slow down ion movement, and due to that will decrease mobility and it will reduce conductance. And if there is smaller hydrated size, that will decrease friction, that will allow ions to move more freely, that will increase conductance due to increased mobility. So when ions are surrounded by water molecules, their effective size increases. This can slow them down and affect how well they conduct electricity. So last we're going to explain here dilution. So first of all we need to understand what is the meaning of dilution. See, the process of adding more solvent will be like water to a solution, making it less concentrated. That is called dilution. Dilution means making a solution weaker or less strong by adding more liquid. Definitely, if the concentration we are decreasing, then definitely the solution will become weaker, or we can say lesser strong by adding more liquid. Mostly we add liquid, that is water. We can take example like adding water to a strong juice to make it less concentrated. So how does it affect? First of all, if I'm gonna dilute a solution, what will happen? It's gonna reduce ion concentration. Fewer ions per unit volume. Another factor will be conductivity decreases. Due to fewer charge carriers, there will be lesser conductivity. However, molar conductivity, what is molar conductivity? Conductivity per mole of electrolyte. As it is clear from name, molar conductivity, conductivity per mole of electrolyte. That often increases with dilution. Due to, first of all, it will increase ion mobility. Here, ions will move freely. It will also reduce ion-ion interactions. There will be less hindrance. So definitely it reduced ion-ion interactions. So diluting a solution reduces the number of ions, decreasing conductivity, but the ions that are left can move more easily, affecting molar conductivity. Now here we are going to talk about how to represent a cell. Representation of a cell. See, this gonna tell us about the phase change. If there is a phase change, this again the phase change. In simple words, if there is a single line like this, if there is a single line that represents a phase boundary, for example phases, that is solid, electrode and solution, and double line, this represents a salt bridge or porous membrane separating the two solutions. So in simple words, we can say single line shows the boundary between electrode and solution, and double line shows the separation between two solutions. Or we can explain in another words like a cell representation shows the parts of an electrochemical cell, including where oxidation and reduction happen. Components must be anode, where oxidation occurs, loses electrons; cathode, where reduction occurs, gains electrons; anode solution, electrolyte surrounding the anode; cathode solution, electrolyte surrounding the cathode. So it is also an example is given here. So another one is electrode potential. What is the meaning of electrode potential? The potential difference, that is voltage of course. Electrode potential is what? The potential difference between an electrode and its surrounding solution. that will be electrode potential. What are the key points now? First is measure of tendency. It will tell us how to measure of tendency, like to lose or gain electrons. It will tell us about oxidation or reduction is happening here, like electrode potential will determine which reaction occurs. Oxidation happens or reduction happens. It will also tell us about standard electrode potential, like we can say electrode potential is a measure of how easily an electrode can lose or gain electrons. So this is known as electrode potential. I just talk about in very simple words. Okay, so another we are going to talk about here, salt bridge, its functions. So let's start it. First of all, what is a salt bridge? Salt bridge is a device that connects two half cells in an electrochemical cell. I repeat this. Yeah, this is the example. This is a diagrammatical representation. Salt bridge, again I'm repeating, it's a device that connects two half cells in an electrochemical cell. Its functions are to complete circuit that will allow ions to flow between half cells. It will maintain neutrality. It means it will prevent charge buildup by balancing ion concentrations, and of course on both sides, because we already talked about that there will be two half cells. So a salt bridge helps ions move between two solutions, keeping the electrochemical cell working very smoothly. So that is a salt bridge. These are the functions. Another is this this construction, how it is formed. First is it inverted U-shaped tube, contains inert electrolytes like KCl, KNO3. So we can see also this from the diagram, ions of electrolyte do not react with ions of electrode solution. Here a word inert electrolyte is used. What does it mean? Electrolytes that don't participate in the electrochemical reaction, those are called inert electrolytes. Inert, word is inert. I repeat, those electrolytes which do not participate in the electrochemical reaction. Inert gases, we already word used in periodic table. What does it mean? Inert means not reactive or participating in a chemical reaction, that is inert. Inert means something doesn't react or get involved in a process. So inert electrolytes do not participate in the electrochemical reaction. They just facilitate ion flow. So another this word, what does it mean? Cell potential or EMF of cell. It means the potential difference. Potential difference, of course, in voltage. We will talk about the voltage. The potential difference between two electrodes in an electrochemical cell, that is called cell potential. It is also known as EMF, that is electromotive force, EMF. It measures the cell's ability to drive electric current. It will be calculated as, you can say, mathematical expression. Cell potential will be equals to cathode potential minus anode potential. Cell potential is the voltage difference between two electrodes determining the cell's ability to generate electricity. So these two topics we will do in another video. So that's all for today's discussion on electrochemical cells. We'll be continuing our exploration of electrochemistry in the next video, hopefully, where we'll dive into this Gibbs free energy and this electrochemical series. So see you in next video. So that's a wrap for today's lecture. Thanks for watching.